All right, Math for College, thanks for your hard work lately. We pick up with these notes. I always got to make sure that I check to make sure I'm doing the in-class notes and not the worksheets. Sorry about that. But we're talking about linear systems of two variables. And systems are, well, it's two lines that intersect. And so I'm going to give you a couple examples here. You could have two lines that go like this. And when we solve a system, we find the intersection point. So that's one way you can have a system of equations. Here's another one. You might have a system of equations that look like this. And in that case, they are parallel, so they have no solution. So you can see the first situation, we have one solution. The second situation, we have no solution. And then the third type of situation we get is not often thought of, but you could have, say, this green line and then another line that sits right on top of it. And we would say that that has an infinite number of solutions in that scenario. So there are three types that we can get. Okay, solve this system by graphing. We look at the first set of systems, y equals x minus 2. So I plot negative 2, and then I use the slope, which is 1 over 1. And as I do that, notice this line that you get. For the second one, I'm going to solve for y. I subtract x, and I get 2y equals negative x plus 6. If I divide by 2, I get y is negative 1/2 x plus 3. So I plot 3. I use the slope of negative 1 over 2. Down 1 over 2, down 1 over 2. Now, as you solve this system, you identify the intersection point. I'm going to say it's about 3.5 for x. I'm going to say it's about 0.5 for, or 1.5 for y. Okay? So I estimated it because it doesn't look like I come up with the exact number there. For your next one, I'm not going to put it in slope-intercept form. I'm going to remind you what happens when we use x and y intercepts. Remember for the first one, when you find the y or the x intercepts, you cover up y, your equation becomes 2x equals negative 4. So x is negative 2. And then if you find the y-intercept, you cover up the x. We get negative y is negative 4, or y is 4. Notice how quickly I can plot those points and generate that line. For the next one, if I cover up the x, y is 7. If I cover up the y, it would be x is equal to 7. So I could plot 7 for y and 7 for x. Notice the graph that you have there. Looks like the intersection point is 1, 6. So sometimes it's nice to put in slope-intercept form. Sometimes it's nice to use the x and y intercepts depending on how the equation is set up. If we don't have a graph, we can use algebraic opportunities. So this is solved by using substitution. Solved by using substitution. Substitution is when you know a variable. So here we have a y equals or an x equals. Because we have y equals, I'm going to take this and I'm going to plug it in for y. Notice now that top equation becomes x equals 2, and then parentheses, I multiply 5 plus 1/2 x minus 10. As I multiply through, I get x is 10 plus 2 times 1/2 x is just x minus 10. You get x is equal to x. If you get that type of an answer where you have the same thing on each side, that means that we have infinite solutions. Or in other words, if you were to graph those lines, they would have been the same line right on top of each other. It turns out that those two are the same lines, so we have infinite solutions. Look at the next one. We have what y is equal to, so we like to use substitution. I'm going to drop it in there for the y. So I have 3x minus 2 times 3x plus 2, and then equals negative 1. Distribute my negative 2 through. I get 3x minus 6x minus 4 is equal to negative 1. Negative 3x minus 4 is negative 1. I would add the 4 to both sides. Negative 3x is 3. Divide by negative 3. X is negative 1. Great. So I have negative 1 for one of my values. I have to find the y value. Well, take that negative 1 and plug it back in. 3 times negative 1 plus 2. And I get negative 1. Turns out that negative 1 is the solution. Now it says solve the following by using elimination. Elimination is a lot of times people's favorite. For example, you can either add or subtract a group to get something to cancel. And you can also multiply through by something. Look at this first example. I'm going to multiply the first one through by a negative 1. And when I do, I get a negative 5x plus 4y equals 0. On the bottom, I get 8x minus 4y is equal to 12. I'm now going to add those together because if I do, I see that the middles will eliminate. The y's will go away. And I get 3x is equal to 12. Divide by 3, and I have x is equal to 4. So 4 is a solution for x. Plug it back in to solve for y. So I get 20 minus 4y is 0. Or negative 4y equals negative 20. So y is 5. Look at the next one. They're both negative, and now they have different numbers. So I'm going to multiply top through by negative 2. That will make it a 6y. And then the bottom I'll multiply by 3. That will be a negative 6y, and then they'll cancel. So negative 8x plus 6y equals negative 22. 15x minus 6y equals 36. And I add. Negative 8x plus 15x is 7x. Notice those cancel. Equals 14. Divide and you get x is 2. So 2 is the x value of my solution. Plug it back in to find the y value. So 4 times 2 minus 3y is 11. Or 8 minus 3y is 11. Subtract the 8, we get negative 3y is equal to 3. So y is negative 1. And that's my solution. To finish off, sometimes you have to make a choice of what's best. Do you use elimination or do you use substitution? I like to use substitution here because we know what y is equal to. 2x plus 4 times x plus 3 is equal to 24. 2x plus 4x plus 12 is 24. 6x plus 12 is 24. Subtract my 12. 6x is 12. Divide by 6 and we get x is 2. Once you have 2, go ahead and plug it back in here. And you can see that 2 plus 3 is 5. So that's my solution. Elimination worked out. This one's a little bit more challenging. You don't know exactly what y equals. And if you divide by 3, you get a fraction. So I'm going to bring everything on one side. 8x minus 12y equals 48. And then negative 2x plus 3y is equal to negative 4. So I brought the 2x over to the other side. Well, I'm going to try elimination. I'm going to multiply the bottom through by 4. The top is 8x minus 12y is 48. And the bottom is negative 8x plus 12y is negative 16. Look what happens as I add these together. The x's go away. The y's go away. You're left with 0 equals 32. This is another interesting solution. Before you had a solution of infinite solutions. Now you get 0 equals 32. That's never possible. So this is a no solution. It turns out that these lines would be parallel lines. And therefore we know that there's no solution. The next one is an obvious elimination problem. I'm going to multiply the bottom through by negative 2. The top is 4x plus 2y equals 12. The bottom I get negative 4x minus 12y is 8. Add them together, and the x's cancel this time. I'm left with negative 10y is equal to 20. So y is negative 2. When we plug negative 2 back in, we have 4x minus 4 is equal to 12. So 4x is equal to 16. X is 4. So my solution is 4, negative 2. That's what we have. All right, folks, that's solving systems of 2 variables. Got a 12-minute video. I'll see you in class, and hopefully you're ready to go. Have a great weekend.